Cisco Certified Network Associate Day 12. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about VLAN Advanced, and that will be that would be a continuation of what we learned in our last video, but we will go into much more advanced topic today. But before we go any further, I would ask all of y'all to go to our Facebook page, that is facebook.com/networking consultant. Like that page, invite all your friends to like that page, because we would be sharing a lot of updates on those pages, and that will be our main point of updates. And of course, don't forget to subscribe to our YouTube channel, which is youtube.com/user/networking inc, or you could just click on the bottom right hand corner and it will take you to our page where you can subscribe to it. Right, so without wasting much time, let's get straight into today's class. So today we would be learning 3 topics, right? So we would be discussing native VLANs, we would be discussing VTP, that is VLAN trunking protocol, and then we will learn about VLAN pruning. Right, before we go any further, let's just do a little bit of trunking revision. So we have learned about trunking in the last 2 videos, so we're just going to revise those topics. So what is a trunk? A trunk is a connection which we use to connect one switch to another switch. VLANs, as we know, are a segregation which switch understands. So only switch understands VLAN, or any other device that can speak the language or encapsulation of 802.1q that can understand VLAN. A computer cannot understand anything about VLAN. So in this picture, right, let me take a pen. Right, in this picture, let me take another color so that we don't get confused. So that's black. Right, so in this picture, this computer and this computer is part of the blue VLAN, right? So let's assume blue VLAN is VLAN 10. And this computer is part of blue VLAN. Now, though I have colored this link as blue, the link does not have anything to do with VLAN. VLAN is part of the port. So this port and this port is VLAN 10 port. So the switch says any traffic that is going out of that or coming in from that is associated with VLAN traffic. So it knows that these 2 ports can talk to each other, but if this traffic wants to go to this red color port, it will not be able to go because they are in different VLANs, right? So VLAN is a concept the switch understands, and switch maintains a table, or the VLAN database, as we discussed in the last video, of which ports are associated to which VLAN. Right, so when switch has a traffic for this PC1, it says, okay, now it checks that traffic and it says, is it part of VLAN? Yes, it's part of VLAN 1 traffic. So it says, okay, so it sends it out on PC1. Now, if that traffic that is coming from PC1 wants to go to PC4, the switch would send it out on this trunk port. So this is a trunk line, right? So this port is associated as trunk and this port is associated as trunk. So the minute this traffic exits out of this trunk port, the switch says, okay, switch takes the frame, it adds one label. So this is a tag, VLAN tag, right? So it takes this VLAN tag and puts this VLAN ID. So that's VLAN 10, right? So it puts that VLAN 10 in this traffic and it sends out. So that frame goes through the trunk, it comes to the switch. The switch takes that frame, it reads that it is part of VLAN 10, so it knows it can only send it out on VLAN 10 tags, and it will send it out on this port, right? That's how it works. So trunking is when these 2 switches are connected, and VLAN tags are used to identify the traffic, to identify which VLAN that traffic is going to. So this is VLAN tags, normally, like I said, goes on to a trunk if at all it has encapsulation.1q that is enabled. That's the only time it can understand the VLAN tag. So this computer, if let's say for instance by mistake, if a tagged traffic goes to a PC, the PC would not know how to read that, right? It's like somebody talking a foreign language to a person who knows only English, right? So a computer will never be able to identify VLAN tags. So these ports are all called the access ports. So VLAN tags would only be associated with trunk ports, right? And like we discussed, this is a layer 2 feature. That means only the switch would know. So what we need to do is to understand VLANs and to understand VLAN tagging, we need to start thinking like a switch. Now switch stays on top of the game and it's like the ruler. Let's assume you're sitting in a room and let's assume that room is the switch, right? And you're the ruler of that room. And you have 5 doors. You say door number 1, door number 3, and door number 4 are part of VLAN 5. That means any traffic coming from that can only go through that group. And door number 2 and door number 5 are part of VLAN 20, let's say, right? So only those 2 people can talk to each other, right? So you know what I mean. So basically, this is a layer 2 feature, and only the switch would be able to understand. Right, so knowing this much, let's get into today's topic. So we start with a concept called native VLAN. Now you might ask, what is native VLAN? So let's discuss that. Like we discussed, a switch port is associated with VLAN. So let's say access port, this access port is VLAN 10, this access port is VLAN 10, this access port is VLAN 20, and this port is a trunk port, right? Similarly in this switch, this is a trunk port, this is VLAN 20 access port, this is an access port with VLAN 10. Now, in the olden days, there was a problem. The switches were very expensive, right? Switches were expensive, so there were scenarios where you would have 2 switches connected through a hub. So this switch makes this as a trunk, right? And it makes this as a trunk, right? And hubs, as we know, does not have these concepts of VLANs. Hubs only know to just copy signals. So whatever signal is coming from here, it'll copy here and it'll copy one on either side. So it'll go on either side. That's what hubs do. Hubs don't know anything else. It doesn't know anything about VLANs. Now, PC, like we said, when any traffic coming from here, it's tagged with VLANs, it comes to PC. PC doesn't understand anything about VLANs, so it just drops it. But what happens when this PC6 wants to communicate with, let's say, PC4, right? So this PC sends a traffic, right? And it comes to the switch. It comes to the switch, and this switch, this port, the trunk port, says, okay, this is a traffic coming from a switch, but that frame does not have a VLAN tag. Now, if there is no VLAN tag, which VLAN will that traffic go into? Will it go into VLAN 20 or will it go into VLAN 10, right? Now, the switch doesn't know that. How will the switch know? So Cisco has a feature called native VLAN. By default, VLAN 1 is the native VLAN. That means if, let's say, there is a PC here, right? And I'm gonna draw a PC, right? There's a PC, and then let's assume this port is VLAN 1 port, right? And let's assume there is another computer here, right? And that's also VLAN 1. All right, so maybe even we could have one more computer here, VLAN 1, right? Now, when VLAN 1 and VLAN 1, if they want to talk, they can talk. They can't talk to any other computers because they are not on the same VLAN. But this VLAN and this VLAN, they're on the same port, so they can talk to each other. Now, when VLAN 1 tagged traffic, when that goes out of the trunk port, what does the switch do? You're right. The switch does not tag it anything. That means the switch knows that VLAN 1 is the native VLAN of switch 2. So it says, okay, now you're from native VLAN, so I'm going to send it out on the trunk, but I'm not going to tag you anything. When this comes here, this switch says, okay, you're coming without any tag. That means you're part of VLAN 1 or the native VLAN, right? So it will put on VLAN 1 and then they can communicate. So these traffic can communicate. Similarly, now this PC, when it's communicating, it doesn't have a VLAN tag. So it says, okay, I can't see any VLAN tag on you. That means you are from VLAN 1. They put him here and then he can communicate with this PC. Now, this doesn't happen in today's world. But what happens in today's world is this. Now, if you're working in any company, you would see if they're using Cisco phones, so you would have a Cisco phone, right? This is how they normally work, IP phones. An IP phone would be connected from the switch port, and the IP phone would link your computer. So the switch port goes to IP phone, and then from IP phone a connection goes to the computer, right? Now, this is a scenario typically what you see in today's world. So how do we connect this? This uses the concept of native VLAN. Now, like I said, computers don't understand VLANs, but phones do understand VLAN. Now, the problem is, can we put our data traffic and our voice traffic on the same VLAN? No, that's a very dangerous situation. Why? Because there are packet sniffing application. Let's say, for instance, Wireshark. Now, Wireshark, if a computer sits on the same VLAN as your voice network, then it's very easy for a hacker to capture the packets, your voice packets, and he can reproduce those voice packets into voice files. So you can literally listen to anybody's conversation. So as a safety practice, as a general practice, voice traffic and your data traffic will not be part of the same VLAN. They'll be separate VLANs, right? So how do we configure this? How we configure a scenario like this is we would make this as a trunk port. So this becomes a trunk port, right? And we say that any traffic coming from this port, right, it's part of, let's say, voice VLAN, let's say this is 30, right? So it says, okay, traffic coming from here, this is VLAN, and like I said, Cisco and most of the IP phones can talk the trunking protocol or the trunking encapsulation, which is 802.1q. You will hear people just say .1q or DOT1q, right? This is the name of this, .1q or 802.1q. It's the same thing. They're referring to the encapsulation of trunking, right? So Cisco's phones understand and talk the language of 802.1q. So whatever traffic coming from here, switch knows, okay, this is VLAN 30, so it'll put on a VLAN 30. Maybe you have another phone connected here, right? And this is also part of VLAN 30, so you can configure the phone. Now, what happens to the computer? What if the computer, now computer in this case, like if you say PC4, this is an access port. Access port, it says that any traffic coming from here, this is on VLAN, let's say 10 because it's blue, right? But now PC5 is coming without any tag because this is a trunk. You don't configure any VLANs on a trunk, right? If you remember, we just create switch port mode trunk. We don't say access like switch port mode access, switch port access VLAN 10, right? So an access port you give a VLAN number, but a trunk port you don't give a VLAN number. So it goes back to the same concept that we discussed in PC6. It goes without a tag. And the switch takes that and says, okay, you're coming without tag, so I'm going to put you in a native VLAN, which is by default VLAN 1. Now the question is this, can you change the native VLAN? And the answer is yes, you can change the native VLAN. But the only challenge when you do that is, like I said, the native VLAN is 1 here, right? And the native VLAN, let's say to accommodate this, and since we know red is 20, we change this native VLAN to VLAN 20, right? Now, when untagged traffic comes here, switch immediately puts it into VLAN 20. Now, if these two switches are communicating with each other, and he says traffic coming from VLAN 20, it says, okay, your native VLAN, so I'm not going to tag you. So it's going to send out without tagging. Now, when this comes to this switch says, okay, you're coming without tagging. That means you're from native VLAN. My native VLAN is VLAN 1, and it is going to put that traffic in VLAN 1, which is wrong, right? So when you're changing the native VLAN, you have to be careful to make sure that all the native VLANs and all the connected switches are changed to the correct ones. Otherwise, you're going to have a lot of problem, right? So this is, in short, the concept of native VLAN. Next, we'll look at VTP or VLAN trunking protocol. The first thing, right? The first thing you should remember is VTP is not a trunking protocol. The name is misleading. It says VLAN trunking protocol, but VLAN trunking protocol is not a trunking protocol, right? So we spoke about trunking protocols in our previous video and also a little bit in the last slide. there are only two trunking protocols. That is ISL. ISL is Cisco proprietary. That is Inter-Switch Link, ISL. And then you have 802.1q, or more popularly known as .1q, which is a IEEE standard, which is the global standard used by everybody, right? So these are the only two trunking protocols we have. But VTP is again Cisco proprietary, and they call it the VLAN trunking protocol. In effect, what they should have been called is a VLAN syncing protocol, or VLAN. Yeah, I think it's a VLAN syncing protocol. You'll see why I say that. Now, when you create VLANs, right? So you create VLAN here, VLAN 10, and you put one computer here. Let's assume, right? You put one computer here, and that's in VLAN 10. Now, when you create this as trunk, now this is trunk and this is trunk. When you send traffic out here, the trunk port is going to tag it with VLAN 10 and it's going to send here. But does switch 2 know about VLAN 10? Because we did not create VLAN 10 here. So if switch says, I don't understand, you're saying VLAN 10, but I don't see VLAN 10. I don't know what VLAN 10 is. So you have to go to the switch and create VLAN 10, right? So this sends that again. It says trunk, so I'm going to send all the traffic again. So it sends here. This switch says, I don't know VLAN 10. So you have to go to this switch again and create a VLAN 10, right? Only then can you associate. So you will go here. You can manually go create access ports. So VLAN 10, VLAN 10. Okay, here you can go create VLAN 10 access port and put devices. Now you say, okay, I'm going to add a new network. I'm going to say VLAN 20. Again, you have to go here, VLAN 20. Again, you create VLAN 20. Only then can you create access ports for VLAN 20 here, and then VLAN 20. Now, as more and more computers and more devices and more switches come into your network, it becomes a very tedious process for you to go and manually create your VLANs on each of those devices. So Cisco said, you know what, we're going to give you an automatic way of doing it, which they call the VLAN trunking protocol. What it does is, when you create a new VLAN, let's say I create a new VLAN, VLAN 30, this gets automatically replicated. It says, okay, add VLAN 30 because I just created VLAN 30. Add VLAN 30 because I just created VLAN 30. You just have to go create your access ports. Whichever computer is connected, so just say access port, and that's done. So your VLAN database is going to be synced across all your network switches, and you just have to create the access ports, which is very easy. I mean, you'll understand if you have about hundreds of VLANs, then it's very, very tedious for you to go to each of those devices and change. Now that's the best part about it. Now, what's the bad part about it? The bad part about it is, every time you make a change to your VLAN database, there is something called as a revision number in your VLAN database. So now usually when you take out of factory reset, everything starts with revision 0, right? Everybody is 0, 0, revision 0, revision 0. When I add the first VLAN, it says, okay, now I am revision 1. So it says, okay, you're revision 1, I'm revision 0. So I'm going to change my database. I'm going to make this revision 1, and I'm going to copy everything from your table to my table. Same thing happens here. He says, I'm revision 0. So I'm going to copy everything from your table, and I'm going to become revision 1. So you go change here. Let's say you go add 20 here. This guy becomes revision 2. So he says, okay, you're better than me. I'm going to say revision 2. Everybody's going to be revision 2, and they're going to sync the database. So every time you change your VLAN database, they check whose revision is higher, and they trust the higher revision number, which is brilliant. The problem is, let's assume you're running out of switch. You have new employees coming in, and you're running out of switches in your network, and you find a spare switch lying in the corner, which I think it was used for practice, or it was used for something. You find a spare switch. You take that switch and you say, okay, I'm going to plug that switch. I'm going to wipe it. So you're going to go say write erase. Write erase is how you delete all your startup configuration. So you say, brilliant, I've done write erase. So now the switch is brand new. Everything is gone. No settings. It's a brand new setting. I'm going to create all the VLAN. So I'm going to plug this here, right? The minute you plug this here and the minute they do all their DTP negotiations and it becomes a trunk, you realize that your entire network just went away. I mean, all your network stopped working. Your computers, your internet, your phone lines, everything stopped working. What happened? What you didn't realize is that this switch, which you were using for training, or which was a spare switch sitting somewhere, had a VTP or VLAN database revision number, let's say 100, right? And your switches on your computer company network may, let's assume, had reached 50. So you were all on 50, right? Everybody was on 50 and everybody was on, right? All your switches were on 50 and they were all happy with, let's say, 5 VLANs, 10, 20, 30, 40, 50. And this switch was in revision 100 because you had made a lot of changes and stuff, and they had only, let's assume, VLAN 100. Right, VLAN number 100 was there in this, and let's say VLAN 5, right? These are the only 2 VLANs that was existing in this VLAN database in this switch. And the minute you connect here, this switch says, I am revision 100. So this switch 2 says, brilliant, we are only revision 50. That means I trust you, you are way better than us. Immediately it deletes all its existing VLANs and copies 100 and 5. And this says, okay, now I am revision 100 because I just copied it from you. Now these guys says, brilliant, you're revision 100, I am revision 50. So it says, okay, I'm going to do this. I'm going to delete all my existing VLANs. I'm going to delete all my existing VLANs. I'm going to update myself to 100 and I'm going to copy all over your VLANs, right? When this happens, your computer network will fail. Why? Because these access ports, you have configured this access port as VLAN 10, right? And you have configured all these access ports for VLAN 10, 20, 30, whatever. Not for 105. These VLANs don't even exist in your network, but now your switches don't have any other VLAN. It only has VLAN 105. Now this is what happens. If a switch port access is configured for a certain VLAN and that VLAN is not existing in your VLAN database, the switches are programmed to shut those ports down. So it'll say, okay, I can see that you're configured for VLAN 10, but I don't see a VLAN 10 in my VLAN database. That means I'm going to shut you down. I can see that you're configured VLAN 20. I don't see a VLAN 20. You're shut down, shut down, shut down, shut down, and shut down. Everything goes into shutdown mode. And this happens. This has happened many times. You know, I've seen at least twice in my lifetime where I've had a situation where our switches were all down and the network was down. We didn't know what happened. And we realized that the only change that had happened before the network went down was somebody plugged a new switch, right? So this is something that needs to be taken care of because VTP is very, very powerful. Now, Cisco would say, as a best practice, not to use VTP because of this problem. It looks very simple and it can destroy your network, but there is some prevention mechanism to it because VTP, when you're part of VTP, it also looks at a VTP domain, right? So only if your VTP domain matches with the VTP switches. So let's say this is running VTP and it has a domain, let's say something.com. And if this has VTP, let's say company name.com or networking.com, so switch 1, switch 2, and switch 3 has VTP domain as networking.org. And switch 1 does not have the same domain, it will not replicate. Yes, so as a prevention, yes, you have some safety mechanisms that only if those domains match will the replications take, but still Cisco recommends not to use it, right? And it's at the end of the day, it's about convenience. If you think it's going to help you, then you can use VTP, and I will show you what are the other safety mechanisms that you can use to make these silly mistakes, right? So VTP has 3 modes. You have server mode, you have a client mode, and you have transparent mode. So let's start with server. VTP server means this is where you can make changes. So if you put a switch in VTP server, by default all the switches come as VTP server, right? That means you can make a change. So if let's say this is switch 1, sorry, my writing is really bad, and this is switch 2, right? And this is switch 3. And if this is server and this is client and this is client, you can only make additional VLANs. You can add new VLANs only at the server, right? So you make a change here, this updates the revision database, it replicates here and it replicates here. But if you go to your client, VTP client, and you try making changes, it will say, I am not a server, you cannot change me. That means it's a mechanism to prevent you from making changes. So this is one way where you can configure those structures and make sure that all the VLAN changes happen only at the server, and clients just copy that. Now you might say, I don't want to use VTP. How do you do that? You can completely disable VTP by going into a mode called as VTP transparent. Now, is there a way where you can say VTP off? No, we don't have a mode VTP disable or VTP off. The only thing closest to not using VTP is to go into a state called VTP transparent. So now what does that do? When you put a device in VTP transparent, so I'm going to say this as T, VTP transparent, what it does is it says, okay, I'm not going to participate in VTP. So if you send me VTP updates, I'm not going to make use of it. I will take it and I will pass it over, right? So the VTP updates will go through this transparent switch and it will go to the client, but it will not act on that updates, right? So this is VTP transparent. It is as good as not using VTP. So remember there are 3 VTP modes: VTP server, client, and transparent. Server is where you make changes, client receives changes from the server, and transparent does not participate in VTP communication. It only relays the VTP updates going through it, right? Next, we talk about a concept called as VTP pruning, right? So let's assume there is VLAN 30 now, right? And there is another VLAN 30 here, right? This is VLAN 20 and this is VLAN 10. Now in this switch, it doesn't have a port with VLAN 30, right? But by default, if there is a trunk, this switch is going to tag VLAN 10, VLAN 20 and VLAN 30 and send all the traffic here. As an administrator, you know that switch 2 does not have VLAN 30. So what we need to do as a administrator, as a network administrator, one of our primary objective is to make sure that you reduce the amount of traffic that is going if there is no use for it. So instead of just using all the bandwidth by sending extra information, that is VLAN 30 traffic through this trunk, when you actually don't have VLAN 30 on the switch, you could make use of a concept called VLAN pruning, and you can tell this trunk that you only send VLAN 10 and VLAN 20 traffics. That means it will avoid VLAN 30 traffic from going onto the trunk. Now that's the concept called as pruning, and we will look in our next video how we configure all these concepts that we're discussing today, right? So this video is only going to be theory of what it is, but how to configure it we will be discussing in the next video, right? So this is what VLAN pruning is. This concept is called VLAN pruning. So we discussed 3 topics today: native VLAN, VLAN trunking protocols, and VLAN pruning. So I expect you to understand these topics today. If you did not understand, feel free to rewind this, watch it again, watch it as many times as you want. And if you have any question, like I said, you can send an email to me, you can comment on our YouTube channel, or you can, best thing would be to comment on our Facebook channel, because that's where we do all the communications, and I'm more active there. And but like I said, you can still go to any of our mediums. You can discuss with us, you can talk to us, you can send us an email. We are ever ready to help you. I understand there are so many emails that I have not replied. It becomes very difficult because I get at least 20-30 emails on the weekends, and weekdays I get about 5 to 10 emails a day. So sometimes if I think something is really relevant, I try to reply, but some people ask, I want your video series, I want your full video series. I don't have it, I can't give it to you. So such emails I just don't reply, I don't have time for it. But if you ask a genuine question and I think I can answer it, I answer those questions and I let you know, right? So thank you so much for watching, and like I said, every weekend, Saturdays, 10 a.m. Pacific time, we would be updating new videos. We couldn't update much. In the last 1 year, we have only updated 10 to 12 videos, but we're going to make a conscious effort to add a new video every Saturday from now onwards. So please don't forget to go to our Facebook page and like it, share it with your friends, go to our YouTube channel, subscribe to it. Thank you so much once again. Bye-bye.